Hello everyone, this is Vikram and welcome to my channel. In this video, we'll see how to build Docker images without Docker daemon. That means even without installing Docker, we will try to build the Docker images inside Kubernetes pod using Kaniko as the build tool. Basically, Kaniko provides a Kaniko executor image. Using that image as the Kubernetes pod, we can build Docker images. In this process, we'll also try to understand what is Docker in Docker concept and why this is useful in Jenkins or in any of the similar use cases. And we'll also try to understand what is the use of var run docker.sock file inside Docker. So let's try to understand first how to build container images or Docker images. So we build Docker images from Docker file, which is basically a set of instructions that are needed to make your Docker image. So once you have the Docker file in place and once you have the Docker daemon up and running, so we can use any of the Docker CLI commands like docker build to build your Docker image. So for this, we need to have a daemon up and running, and we should also have a client tool called Docker CLI so that this Docker CLI can talk to the Docker daemon for building the Docker image. Now, how does this Docker CLI talk to the Docker daemon process for building your Docker image? Basically, the Docker daemon process, which is running on your Docker host, listens actively on a unique socket. So this is the socket, which is var run docker.sock. In the daemon process actually listens on this Docker sock. And any of the CLI tools or external utilities, when they want to talk to the Docker daemon process, they have to talk to the Docker sock. And since daemon is actually listening on Docker sock, so we can directly execute the commands on the Docker daemon process. So this is the use of var run docker.sock file. So it is basically the unique socket in using which the Docker daemon actually listens on by default. And let's assume that you need to talk to this Docker daemon from within a container. Let's say that already I have a container called Ubuntu container, which is actively running, which is in the running state. So now from within the container, I wanted to build a Docker image. So from within the container, if I have to build a Docker image, so I should again have to have the Docker daemon inside the Docker container. So having the Docker daemon within the container and also outside the container makes so much of complications inside the host. So what is the next best alternative? So the next best alternative is having the Docker CLI inside any container. And we all know that this CLI, if it has to talk to the daemon, it needs access to the Docker sock. Now what we'll do is we'll take this Docker sock and we'll mount that into the container at exact location, which is var run docker.sock. And since we have the Docker CLI, so this Docker CLI from within the container can talk to the this Docker sock. So this Docker sock, since it is mounted, so you are indirectly talking to the Docker daemon process, which is running outside your container. So without having the Docker daemon inside your container, so you only have to have the Docker CLI and the docker.sock mounted at the exact location to talk to the daemon process. So now from within the container, I can also issue commands like docker build, docker ps, or any of the command. So these command directly talk to the daemon which is running outside your container. So the way we mount is using the volume mount. So we are taking the var and docker.sock, which is src, which is basically your host, and we are mounting into the container at exact location. So mounting this var sock gives the ability to talk to the daemon process from within the container. So this is also known as Docker inside Docker, or also known as DIND, which is called DIND. Now, what is the use of mounting the sock file into the container? So let's understand Docker inside Docker for Jenkins and why Jenkins needs Docker inside Docker. So in any of the CI pipelines, so we'll have a lot of stages. So the stages like checkout stage or building your Docker image or compiling a source code, there are hundreds of stages that can include in your CI CD pipelines. So in CI pipelines, basically we use Docker containers as build agents because let's say that you wanted to have Node.js based environment to compile or pack your Node.js application. So instead of having Node.js installed in an agent, so we can take Node.js as the Docker container agent to compile your Node.js application. So for this, we'll be using Docker containers as build agents, and in some of the stages, you'll be having building the Docker image stage. Let's say that I have a Git checkout stage which is checking out my source code, and now in the next step I'll build the Docker image, that is I'm containerizing my Docker application, or I'm containerizing my application. So let's assume that this repository has the Docker file. So now using docker.build I can build my Docker image. But how this is going to work? Let's assume your Jenkins container itself is running as a container. So I have this Jenkins container, so running inside the Docker host. So now in order to issue docker.build within the container, it should have an active daemon running inside the container, which is practically not possible. Now we are going to use the same method. Since we already have a daemon which is running outside your container and it is actively listening on var and sock, so we are going to take this socket and we are going to mount inside the Jenkins container. And this Jenkins container, from within the container, it can issue Docker commands. And this Jenkins containers, one more requirement is we should have the CLI installed so that Docker commands can be issued. So this is called as a Docker in Docker, which is pretty much useful in case of Jenkins, because in Jenkins we'll be using build agents to build various projects, and also we'll be using Docker build commands to build the Docker images from within the Jenkins container. So the only requirement is we have the Docker CLI, which is inside the Jenkins container, and an access to the docker.sock. Basically this is the sock which is in your host machine. What we are doing is with volume mount -v, we are just taking this mount, we are just taking this file and mounting it into the exact location within the container. So now from within the container, if I run docker.build, because I have the Docker CLI installed, so this docker.build will try to talk to this file. And since this file, it is just a link to the file which is existing outside your machine within the Docker host, so directly we are talking to the daemon. So even though we don't have the daemon within the container, so this is the usefulness in case of Jenkins, where Jenkins has to use a Docker exclusively for various stages. Now how do we put a Docker CLI or Docker Compose CLI or any CLI within the Jenkins? So we are going to take the Jenkins official image, and then we are going to become root, and then using any of the package managers like apt, so we are going to install a CLI. So this Docker like we don't have to have the daemon. So if you have the CLI, that is also sufficient. And then if you have the CLI, and if you can also download the Docker Compose if there is a requirement. So we are going to put both CLI and Docker Compose inside the bin directory. So within the container, so the container can recognize Docker and Docker Compose command. So by default Jenkins container should run as Jenkins user, so we will switch the user back to the Jenkins. So now if you have this Jenkins file, so I'm going to create a new Jenkins image with the Docker CL and Docker Compose inbuilt, and I'm just tagging it as Jenkins Docker. So this is the Jenkins Docker I'm using. But as I said, if from within the container, if you want to execute Docker commands, I should have access to the Docker sock file. So this is the sock file, and I'm using volume mount to mount that socket of your Docker host into the Jenkins container. Using Docker in Docker has a lot of security concerns. So one such concern is the Docker build containers run in privileged mode. This is a kind of bit security concern because we are indirectly opening the door to the malicious attacks. So anyone who has access to the Jenkins container, or anyone with the proper access to the Jenkins UI, can create the pipelines so that can fetch any image from the outside, and then it can run, Jenkins container can run that image. So unnecessarily we are giving the privileged mode access to the Jenkins container. And one more thing is, so we are saying that we are mounting var run docker.sock into the Jenkins container, but recently Kubernetes removed support for Docker. So Kubernetes altogether removed Docker from its core. So mounting docker.sock is practically not possible because we'll not be having Docker installed at all. So unless you have the Docker installed in all the Kubernetes node, so mounting docker.sock is not possible. Now we understood that using Docker in Docker is a security concern, and at the same time Kubernetes removed Docker from its official Kubernetes binaries. So now how do you build these images in your CI pipelines or within the Kubernetes cluster where we don't have the Docker daemon process up and running? So enter Kaniko. So what problem Kaniko is trying to address? As we all know that Kubernetes is deprecating Docker as container runtime. It already done this after version 1.20. So we need another way to build container images within the Kubernetes cluster, provided you don't have access to the Docker daemon. And we also know that Docker in Docker requires privileged mode to function, so which is a kind of security concern. So this is the very issue that Kaniko is trying to address. So now what is Kaniko? Kaniko is a tool to build Docker images from a Docker file, which we already know, but it does this from being within a container or inside a Kubernetes pod. So we don't have to have the daemon up and running. So this image build process occurs from within the container even without having the Docker daemon active process. So every command within your Docker file will be executed completely in an isolated user space. So this enables building container images in such environment where we don't have the active Docker daemon process, or using Docker daemon is a security concern. Now Kaniko is meant to run as an image. So the way Kaniko build your container images from the Docker file is by using an image known as Kaniko executor. So this is the name of the image. Basically this image has a Go binary that is able to build your container image from the Docker file. But if you try to use this Kaniko executor binary inside any other image, it may not work as expected. And Kaniko has another image, which is the debug image. So this debug image also has a shell inbuilt. So if your build container requires a shell, so you can also go for debug. So this Kaniko executor image is responsible for both building your container image from the Docker file and also pushing it to the registry. So the way it does is, so we'll be creating a Kubernetes pod based out of this Kaniko executor image, and we'll be supplying the Docker file. So once it has the Docker file, it is going to execute all the commands from the Docker file, and it will build your container image, and after building it can also push it to any of the registry. So within the executor image, so Kaniko extract the file system of the base image first. Let's say that the base image I have is Python. So first what it will do is it will try to extract the file system of Python image, and from there it is going to execute one statement after the other in the Docker file, snapshotting each file system in the user space. Let's say that there is second instruction in the Docker file. So it executes that second instruction, takes the snapshot of the complete file system in the user space, and then it will move on to the next step in the Docker file. So after each command, it appends a layer of changed files to the base image, and it will update the image metadata. So this is how it will build your container image from within the Kubernetes pod. And what are the things that Kaniko executor image usually expect to build your container image? So the most obvious one is the Docker file, which with your build instructions to build the container image, and also the build context. So let's say that you store your source files in a directory, and inside the directory only you have the Docker file. So this is the build context, so which is similar to your Docker build context. So without build context, it becomes difficult for the executor image to find the correct context. So we have to give the build context with the set of source files and the Docker file. So currently your Git repositories, local storage, S3 buckets, blob storage, Google Cloud storage are all supported. And now once we have the Docker file and build context, and once your Docker image is built, so where to push it? So this is defined in the destination. So destination can be your Docker Hub account, or it can be any of the private registry. Or if you don't want to push the image at all, so you can use -- no push flag, so that we can skip this particular stage. So now let's go to the official Kaniko documentation and see how to use Kaniko. Now this is the GitHub repository for Kaniko. So if you scroll to the bottom, so using Kaniko you can build images in the Kubernetes, and it is basically a tool to build container images from a Docker file by being within a container, or from within a container basically, or from Kubernetes pod. So you can have a Docker image built inside a container or inside a Kubernetes pod. And Kaniko basically doesn't need a daemon process, so which we already seen. So now this is the complete documentation. So we can see the build context supported. So we have Git repository as a build context or local directory, or it can also support any of the storages in your cloud. So you can go through this complete documentation to get complete picture of how Kaniko works. And I also have the Git repository called Kaniko demo, so where I have the Python source files, and I also have a Docker file. Basically it is a simple Docker file with Python as the base image, and then I'm installing Flask using the pip inside that image, and then I'll set the working directory, copy app.py file from the build context, and then the entry point is Python app.py file. So within the Kaniko demo repository, so I have the app.py file, and I have three different examples on how to use Kaniko to build the Docker images. And I also have the Minikube cluster up and running, so I've already started the Minikube cluster. So let's first try to understand the example one. So this is the example one. So as we said, we can build the container images from within the Kubernetes pod. So I have the pod manifest file, and this is the basic definition. And inside this spec, I have a container called Kaniko, and this is the Kaniko executor image, which is the latest, and the argument. So these arguments, as we already discussed, so Kaniko executor expects three different arguments. So one is your Docker file, the other one is the context, and third one is the destination. So Docker file is the name of the Docker file within the repository. So if you go to the repository, I have the Docker file with the same standard naming convention. So this is the one which I am using. And the context, so what is the context? So as we already said, context is something which is hosting your source files, or the one which has the Docker file. So the context can be your Git repository or local storage or any of the cloud storages. So for this demo, I'll be using Git, and this is the URL to my Git repository. And the destination, so where should I actually push this file or Docker image after building? So I've given my user account and followed by the destination, the Docker image and the Docker tag. So once the image is built, it is going to get pushed to the my Docker Hub account. And in order to push to the Docker Hub account, so I need my Docker Hub credentials. So if you go to the repository inside the README file, so I've already shown the steps on how to create a Docker registry secret using kubectl create secret, Docker registry secret, and the name of the secret is registry cred or reg cred, and the Docker server URL, Docker Hub username, and Docker Hub password. So these are the mandatory things. So you can ignore the Docker email. So this is not needed. So first thing is I have to create this secret. So this secret is called the reg secret, and then inside the secret, so there are various paths, okay, items. So key is this one and path is this. So I'm going to mount this secret into this path. So I have volume created, and I have the volume mount, so that is mounting my secret, because Kaniko needs that secret information to push your Docker image to your registry. So this is where I have to mount, which is /Kaniko/Docker. So once you have the volumes in place, so once you run this pod, Kaniko is going to pull your source code along with your Docker file, and then it is going to build and it is going to push it to the remote repository. So first what we'll do is we'll try to create a secret, because secret is mandatory, without which your pod will not start. So first let me take that particular command. So this is the overall command, and then I'm going to go to the terminal and enter. Okay, so first I'll change everything. So it is kubectl create secret, Docker registry reg cred, and this is the Docker server URL. So this is my Docker Hub basically the account name, and I'm going to enter my password as well here. So once you have the password, so you can easily push your image. So I'm just inside inputting my password. So here my registry credentials are created. So I'm just going to clear the screen. And now once you have the secret, so now I can run this part. So I'm going to open this particular file in the terminal, or you can also go from the command prompt. So I'll be using VS Code directly. So I will be applying this manifest file. So how do I apply the manifest file? It is kubectl apply -f example 01.yaml. So it is saying pod is created. So if I just do kubectl get pod, so you can see that Kaniko pod is being created. And I also can check the logs using kubectl logs -f and the name of the pod called Kaniko. So now if you see, it is trying to pull your files, and then if you see, it is executing each and every line of your Docker file. So from the base image called Python 3.9, so it has pulled all those dependencies, and then it is pushing the image to my remote repository in the final state. So push is successful. So I've already verified it before, so I'm not going to open it again in the Docker Hub account. So if you check the build log, so what it is doing is, so it is taking the snapshot of the file system. So once it execute each and every command, so taking the snapshot of file system, taking the snapshot of file system, taking the snapshot of file system. So all these snapshots get merged into the base image, and once the image is ready, so it is going to get pushed to the remote repository, sorry, your Docker Hub account. So now if I just do kubectl get pod, so this pod is there in the completed state. So let's delete this particular pod first before going on to the next one. So now if you open the example 2.yaml, so here let's say that you don't have the source file or the build context in the kit. You have the build context within your local machine. Okay, so within your local machine you have the source file. So here I have the volume called app files, and I'm going to use the host path as the Kubernetes volume. So this is a type directory, and what is the path is, so basically this is the path in my local machine. So if it is your Linux, so use appropriate path. So in this path I have all my source files which we are currently seeing in this Git repository. So I'm going to name this host path as app files, and these app files I'm going to mount it into /workspace. So why I've given /workspace here? So if you try to go into the Kaniko image and try to see the executor help section, so what does this executor help section says is, so if you have the context, so that is where you know your executor is going to find all the files. So the default one is /workspace. So if you don't give this /workspace, the default one the default one is /workspace basically. And now if you try to see the Docker file location, so which is hyphen Docker file, so hyphen Docker file, so the path to the Docker file, so the default one is Docker file. Since we already have Docker file with the same name, so even if I exclude both Docker file and also the context, because these are the defaults and I'm using the defaults in my manifest file, okay, so I can ignore those flags in my arguments. If I go back to the the previous example, and if I try to show side by side, so here I have the on the right hand side I have the Docker file and context as well, but in this new file I don't have the Docker file, because anyways I'm using the same standard naming convention, so I've ignored it. And also the build context, so build context, the default one is /workspace, and I'm copying or mounting the app files volume in the same /workspace. So I can also exclude the context here, but destination I will put it because I wanted to push this image to the Docker repository. So and this is the another secret, so the secret which is holding your Docker Hub credentials. Okay, so now I'm going to execute the second file. So it is kubectl apply -f example 2. And then if I just use kubectl logs -f, so basically it's Kaniko. Again, it is doing the same thing. So it is using the Docker file to build the image, and at the end it is trying to push it. So once it is pushed, so the job is going to get completed. And after this, I'm going to delete this particular pod. Let's see if I give the path wrong, what will happen. So instead of Kaniko demo, so I'm just giving to Kaniko demo 2. So this path is not existing. So let's see what will happen if that path is not there. Now if I try to check the logs, so the pod is still in the creation state. So it is saying waiting to start. So if I have to see the describe, so using kubectl describe pod Kaniko. Now if you see, mount volume failed because this app files is not existing. Okay, so this host path basically is not a directory because this is not there in my local machine. So this is how you even verify whether we are using the correct host path or not. So I'm just going to delete the existing pod. I'm going to revert the changes as well. Now let here what we did is after building the Docker image, we are trying to push it to the repository, but I don't want to push it to the repository. So if you don't want to push it to the repository, so in the destination, so I can just use -- no push. So using -- no push, my destination, like the Docker image won't be pushed to the Docker hub. So if I just compare it with the example 2, so what I did is I removed the secret because I'm using no push. So secret is not needed, but I need volume mount because I need to build the image. So okay, so in the destination, basically I'm using -- no push. So if I try to execute this command, this file, if I apply this file, so in the build log, so you'll be able to see that the image won't be pushed. So the existing pod is getting deleted. So we are going to stop the demo here because there is nothing new in this. The only thing is your Docker image won't be pushed to the Docker hub. So once the Docker image is built. So that's it for this video, and I'll see you in the next one.